Okay, welcome to another video once again. Today we're gonna cover syllabus 1.2, second part of the first topic, which is information representation and which is multimedia. So we are gonna deal in today's video about non-moving multimedia. What do I mean by that? Well, your images. How are images encoded in your computer system? What are the two common types of image format that you will be using? So we all know images, they are either they look like an animated image or they look like a realistic image. So one is a raster file, another is a bitmap file. A raster file can be called as a vector file and a bitmap file, right? So the syllabus demands candidates should be able to show understanding of how data for bitmap images are encoded, use and understand the terms pixel, file header, image resolution, screen resolution, color depth, bit depth, perform calculations to estimate the file size for a bitmap image. So the understanding of effects of changing elements of a bitmap image on the image quality and file size. Use the terms image resolution, color depth, and bit depth. Okay, let's start with bitmap file first. Whenever you see an image that looks very realistic, you know that it's not AI generated. Now, AI generated is a completely different topic. It's completely out of the scope of our syllabus, so we won't deal it. So, pictures taken from your phone's camera, pictures taken from DSLR camera, webcam, these are all bitmap files. How are these created? Well, the sensor of the camera captures the light that falls into the sensor, an analog to digital converter, or a camera sensor for that matter, converts the analog data. What is our analog data? The colors, the pictures, the rays of light into a bit form. That's why bitmap. We're mapping the analog data into bits. So ultimately it's zeros and ones only. But the analog to digital converter does its work. And we have a bitmap image. Okay. Now let's understand some terminologies associated with bitmap image. Firstly, there is a thing called pixel. Pixel stands for picture element. It's the smallest part or an element of a picture. So when you keep on zooming up a picture to it and and go on to the extreme side of zooming, you literally see some boxes. It's not clear, it's blurry, and these boxes have colors, and with the combination of these colors a picture is made. These blocks, the small blocks, are called pixels. And whenever you zoom a bitmap image, it goes through a problem called pixelation. Pixelation is a situation where you overly zoom a bitmap image and it appears to be blurred. This is a problem with bitmap image which you need to frequently mention in your exam paper. The more the number of pixels, the less chances it will have of pixelation. That's why a general rule of thumb whenever we're deciding on a phone to buy whether it has a good camera or not was through megapixels. How many megapixels does it have? How many 10 to the power 6 pixels can the camera capture? Meaning 12 megapixel camera would be able to capture 12 1 2 3 1 2 3 pixels in a single image. Now, more megapixel does not always correlate to better picture. It comes to sensor size. If we had to explicitly mention or talk about smartphone cameras, it also comes to software as well. How efficient is this software in terms of encoding the picture? So, this is about pixel. What about image resolution? So, Pixels, as I've mentioned, is a collection of, or is a smallest element of a picture. Resolution is when you multiply that pixels on width and length, let's say. So this is how our screen is basically made up of millions and billions of pixels of LED. They light up behind our back, behind the back of our display, and they show combination of colors. So if my screen has this many pixels, what's the resolution? Well, I have 1, 2, 3, 4, 5, 6 columns. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 rows. Sorry, my bad. Columns and rows. My bad. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 times 6 is equals to 84 pixels. Oh, so a picture that is made up of 84 pixels would not be very clear. This is what it means. Image resolution is the number of pixels of an image, number of pixels in its breadth times its length of a image. Screen resolution, same thing of a screen. What's color depth? Well, whenever you're representing an image, you need to allocate how many bits I'm allocating it to represent a color, such as a single bit image of color depth will be black and white, 1 representing black, 0 representing white. Whereas a 3-bit number could represent how many colors? Well, 1, 2, 3. This is 7 colors. An 8-bit could represent 255 different colors. So a 8-bit display is very much appreciated by digital content creators, digital marketing specialists, as they could have a very good idea about the colors quality, hue, saturation, and everything. The best display would be 10-bit display. It can have 1024 different variations of colors. So increasing the bit depth would increase the accuracy and color correction of the image, but it would also increase the file size. Increasing the image resolution would also increase the number of file size, but it would also increase the precision or accuracy of the image. How do we calculate image size or screen size? Well, you multiply rows, number of rows in pixels times number of pixels in columns times bit depth. So we have an image of resolution 500 times 500, and its bit depth. Okay, so bit depth and color depth, they're pretty like same stuff. So when you're using a vague term, you use a bit depth. So bit depth could represent the depth for sound, audio, video, image. Color depth is bit depth, but basically it's specific for images only. That's the difference between color depth and bit depth, and it's in a number of bits used to represent a color, and times color depth or bit depth. So if we use a 8-bit bit depth, we have 525 1 2 3 4 times 8. This is 25 times 2 2 0 0 1 2 3 4 bits. Now if I had to convert it into let's say kilobyte, not kibibyte, kilobyte, what do I do? 2 1 2 3 4 5 6 divided by 8, it goes into bytes, and I divide by 1000, it's in kilobyte. If I again divide by 1000, meaning to the total value, it goes into megabytes. So this is how file size is calculated. You cannot use a calculator, so they will most probably give a value that's easily divisible by the 8 in the denominator we have. So these are the calculatory or calculation stops that you need to have an idea of. You know how to estimate a file size. So the keyword is estimate, so you're good to go. You don't need a precise calculation. Now we will start with vector graphics in the next video. So stay tuned. We will also talk about how do we justify which image type do we need to use. Is vector graphic better suited for our needs or bitmap image? This will also be dealt in the next video. Within that time, stay tuned. See you soon.